Howdy folk, I hope you guys are doing well today. Today we will be exploring the macOS Banshee stealer written in Objective-C. I'm really excited to go through this project as I commonly don't go through macOS malware as I don't really have a need to write it much. However, it's quite exciting to see that the source code for a real world malware has been leaked, and briefly looking through it, it's quite easy to understand and and follow the flow of the malware. And hopefully, you'll have a great time and enjoy exploring this piece of malware with me and gaining a deep insight into its functionality and how it works. To follow along, you can download the source code from the malware source code repository by VX Underground under macOS Stealer Banshee, and the password for this 7-zip folder is of course infected. So while I do not expect you to know Objective-C to gain an understanding of this project, I thought it'd be useful to just do a very quick crash course on how Objective-C kind of differentiates itself from C, kind of all you really need to know for the extent of this class. So to define a class, the interface for this class, typically in the header file as we can see here, you define it as interface, and it must inherit from the NS object. The NS prefix is part of the foundation kit, and it pays heritage to the Next Step project, which was something related to Apple 10 to 20 years ago when they acquired the Next Step company, I believe. So when we have an interface, we can define properties of these interface, essentially member variables, and additionally we can define methods that can be run against this class with this minus sign, the return type, the method name. We can additionally, the method can take parameters, and these parameters have, of course, similar to the C syntax, the method type, and then the parameter name. Additionally, we can have multiple method parameters. And one other thing I think that's important to know is that while we can have instance methods as defined up here, we can also have static methods, kind of how we have it in C++, which I define with the plus sign. That's kind of all you need to know. And then one other thing, in Objective-C, this bracket syntax is used quite a lot. You can just kind of almost read it as calling a function. So this would be like controller alloc dot init with encryption key. That's kind of how I read it, and all these. I think that's quite an easy way just to read it. For example, this would be task.launch, and it quite literally could be written as task.launch, or well, it can't be, but that's kind of just how I read it. And for example, if I just want to understand what it does, we can go to its definition. But of course, that's something we'll dive into later. But once you've downloaded that source code, you can either open it up in Xcode project and just add the sources and headers and the main file as part of the project, or you can open it up in Visual Studio Code. If you are using the C++ extension pack and Clang D, you can write a quick CMake list and you can configure your project just to use the Clang kit. And what the CMake list file does is just generates the stuff we need so that we can have IntelliSense provided with this compile commands through Clang D, and this just adds the source files, so main and the sources in here, and then it adds the header files, also defined here, following the project structure. We then link to the foundation kit, which is kind of, the way I like to think it's like the C runtime for Objective-C on macOS, and we just set the target properties to get everything to work. Pretty dead simple. You can copy this and use this in your own project if you want to compile this. But without further ado, let's actually get into the actual malware content. And first thing I like to do, well, we've got the main entry point. What I like to do is just briefly look through the header files, look through the names of these headers to kind of gain an understanding for what kind of functionality can I expect or should I be on a lookout for. Be quite quick, but we can just start with the anti-VM class. We can see that there are three static methods: one to check VM, is debugger attached, and then is the Russian language installed. These will be pretty simple, and then the actual implementations for these interface will be defined down here. But let me not tempt you and dive into that just yet. Let's just browse through these other files here. So here we have another class called browsers. It's got quite a few properties, which are strings. It's got an array of strings for extension IDs, a method called collect all data and collect all data and save, and that takes in three parameters: the browser name, the path to profile, path to save, and these are both class methods, and this is a static a static method, I believe. Oh yeah, okay. And then we've got controller, and this seems to be the main part of this, like where everything is put together. And this has references to the tools class, the anti-VM class, the system class, the browsers, sender, wallets, and then it stores this encryption key, which we remember briefly seeing, but we haven't dived into yet, as a property. We've then got some globals. I assume this is what's used as part of their build tool. This is the remote IP. I assume this reaches out to an encryption key that is just left as RT, some build ID, and some of the other external variables. This sender, okay, the functionality speaks for itself in the variable name, in the function names: send data and post data to C2 server. We can get we can get an idea about what we expect the implementation to consist of when we see references to it later on. We then have another system class. This is the initialization method, and then we've got several other methods on this class, which look all like they're grabbing some information that we can explore later on. Right now we're just scouting the malware to kind of gain an understanding of what it does. And here we've got this Zorky and some sort of encryption macros. And now we've got another tools class that has a couple static methods to execute what looks like to be a command, and just some other stuff. I won't dive into too much what that may mean. And now we've got one final class, which is collect wallet data, which I think we won't be too surprised about when we see it implemented. So now we've got kind of a brief idea about what we can expect. Let's dive in straight into the source code. So if it has more than one argument and the second argument is run controller, then it will get the encryption key from the second parameter and it will initialize the controller, which we remember seeing here as kind of like the glue putting everything together with this initialization function. And if we jump back, we can see it using the second parameter to initialize it, and then it'll, from the controller, once it's allocated and initialized it will hit this manage function, which I assume is the core logic of this entire program, and return out. However, if it's not, it will create a task, an NS task. Let's quickly Google that. Okay, so it's just a sub-process of the current process. It'll set the launch path to the executable path of our, I assume this would be our current process, and then set the arguments to be run controller matching this set the first parameter, and the encryption key the second parameter. And we remember, if we saw earlier, the encryption key was just @RT. It will then launch this and kill the terminal. So that makes sense. So it doesn't really show anything to the user, and then it'll wait until exit. Pretty dead simple. So essentially, this does, it will relaunch itself with an encryption key, kill the terminal, and now this is probably the functionality that we should be interested in. Without further ado, let's dive into this manage function. Awesome. So if we remember earlier, the controller has this initialization function which takes in the encryption key, which is the second argument passed when this relaunches itself. It then has this this class method called manage, which is invoked by the main function, and then it has several properties which store the tools, the anti-VM system, browser, sender, wallet, and this encryption key property. And one thing we didn't dive into is, if we go back, is when it's initialized with the encryption key, it calls the superinit. So it calls the initialization function for NS object, and once it's done that, it'll store the encryption key as the property. 1 second, if we remember back here, and then it just allocates and initializes system, also again with the encryption key, and then it just initializes, allocates the memory for tools, anti-VM, browsers, sender, and wallets. And once it's done that, it will return back the new instance that it's allocated. So if you remember, it allocates with and initializes with the encryption key, and then calls into manage. So once it's in manage, we've got this anti-VM class, and with the very apparent name isDebugger attached, it's just calling the isDebugger attached method of this class. The static method. And what this does, it allocates this 4-byte array, size of 4 integers, and it info proc, and this essentially makes a system call, passing in this information that looks like, we can Google it. Okay. So let's see what this does. Probably what would be better to actually understand how this works is, alright, so yeah, ptraced. Okay, so it looks like, yeah, there's an example of being debugged. It looks like it's just something straight from Google that really just initializes a an array of the information it's going to query for. So it's going to query the current process, and then invoke it, and then from the returned information, check if it's being ptraced in the structure, and then if that's not equal to 0, then it's being debugged. And then the second check it makes is system profiler, and so it runs this command, and that implementation is here, but let's just look at what this does. It runs this command, and it looks for this information. So we can run this command on my Mac, and so I can assume that if it was on a virtual machine, this information, if it contained virtual, it would think that it's running in a virtual machine, and based on that, it would return out. So this run command implementation takes a string, and this string here, and really what it does, so it creates a pipe, and wait, one sec, self dot run command, passing this command in. Wow. Yeah, this Objective-C syntax sometimes does confuse me up a bit. P open. Okay, so this is just starts a process. Okay, makes sense. So this starts the process and then just gets the output and stores it in this buffer. And while it's storing in that buffer, it appends it by converting it into an NS string and appending it to this result. And then as this result is an NS string, we can use this method to check if it contains this string virtual. Awesome. Objective-C, it sometimes looks weird, and it's naturally not. I'm not as familiar as I am with Windows, but I always like a good challenge. So next thing it does, it uses the tools class, and it invokes this method, initialize global temp path. So where is this temporary path? Okay, we remember seeing this temporary path being stored as an extern here, and it gets the temp directory folder, which is literally just either it gets the environment variable or just uses temp, and then it generates a random string of 25 characters, and it creates a temporary folder using the NS file manager default manager. If the file doesn't exist at a temporary path, it will create it with create intermediate directories. Alright, we can Google that. Path. Okay, this one. Yep. Yes, attributes with the given attributes. Okay, so it looks like it just creates this. Don't need to overcomplicate it. So it looks like this just creates a temporary directory under temp with appended with 25 random characters, and creates that if it's not already created. Let's just jump back. So once it's done that, it calls the system class get macOS password. If we remember, this is what it initialized with the encryption key, and that just calls the parent class NS object. It initializes it and just stores the encryption key as locally in the class. So now we can look at the implementation for get macOS password. So the first thing it does is get the username, and as we remember before, the NS is next step, and then it runs this dialog command, say script display dialog. To launch the application, you need to update the system settings. Please enter your password with the title system preferences with icon caution default giving up after 30 with hidden answer. So I ran this before, and what essentially this is that it will show up a pop-up. So normally you have to put in your password. It kind of looks quite similar to this. So if you do like ASDF we can see that it returns ASDF. So if I put my password, it puts in your password. And any Mac users know those pesky updates, always spamming, hey, update this, update that. So that I would not be surprised if this actually does work. So this, I assume, just executes this command and then captures the return value, and once it's got that return value from this, it will attempt to verify the password, and it does that using DSCL. DSCL. Okay, so this is just something that you can use to authenticate to the local directory services, and local default auth only with the username and the password, and we can see that it uses the username from NS username and the password that it gets from extracting the substring from this return, so whether this is returned here, and then it tries to do this 5 times to get the password, and it will try to verify the password, and if it does that, it will store this in this global variable, and it will hit the debug log, which is just nslog. nslog in debug builds, but in not debug builds, it's just nothing. Gotcha. So pretty simple. Well, we can jump back here. So this just gets the macOS password. Get the current user password with say script prompt, and we can put some notes here. Initialize global temp random 25 jars, and here check if system, what was that, yeah, if model identifier contains virtual, check application is being ptraced. Ptrace is essentially debugging. I wonder if there is man ptrace. Oh yeah, process tracing and debugging. So once, we can just put a line up here. Once it's got the current user's password, it then uses the browser's class to collect all data. So let's have a look through this. Oh yeah, one thing we missed is during the initialization, it just stores the Chrome path to the OperaGX path as these paths on disk, and then it specifies collect data from browser, and it does that for all of the browsers. It takes in the browser name as the browser name and the browser path, and surprisingly as where this was initialized up here. So we can imagine Chrome and Google Chrome as the inputs for the browser name and browser path respectively. It first uses the NS home directory and the browser path, and it format strings that, so, and it stores it in this variable, and from there it gets the profiles for the browser path home directory, which is this format string, and then the browser name. How does this work? So let's just jump back here. Self-get profile, browser home path directory, and browser name. Let's have a look at what this function does. Okay, so this just lists the contents of the directory of the path, the, the contents of the path, the paths of that directory. Sorry, and for all the entries, it creates the full path by appending it to the browser path, and checks whether the file exists at that full path, and it stores the is directory to the output variable here. And if it is a directory and the browser name is one of these, and the entry is equal to default, or it has a string prefix profile, then it will add the object to this profiles array. Else, if it's the browser is equal to Firefox, then the entry is called default release. It will store it here. Okay, yeah. So default release as Firefox profile. Okay, gotcha. Makes sense. So this essentially gets all the browser profiles. Oops, go back. Okay. The first thing it does, it gets all the browser profiles here, and the next thing it does for all the profiles, it formats the browser name and the profile, and if the browser then formats a different profile path folder, and then it uses a temporary path with browsers and profile path folder, creates this directory, and then it collects and saves data. Okay, so once it's got all the profiles, it will collect, and it has wait one sec, let me jump back, the browser name, so Chrome, and then the path to the profile, and then the path to save the profile data, which is a temporary folder. So if we jump back to here, it essentially stores the web data, history, cookies, the login data, and then for Firefox in particular, the SQLite databases and logins, some more databases. So essentially just copies all of these to the destination directory. Wait 1 second. Oh, the destination directory, which is this path. Path to save appended with this information. So as opposed to storing it all in memory, one thing this does is it stores it to a temporary folder on disk. That is terrible. That is terrible and lazy. Wow. I'm sure they have a reason for that, but wow, that is terrible and lazy. So it does that for all browsers. And I assume wait, let's just, yeah, that's it. Okay, wow. Get all browser profiles and copy the data for each profile into the temporary folder under a respective structure. That is pretty lazy. Wow. I just want to look at that again, just to make sure I'm following that correctly and I'm not wrong. So it makes this, uses a temporary path, and then the profile path folder, which is the browser name and the profile. So it formats that. So Chrome and then my profile. It creates the directory. It passes this directory, which is this format string here, into collect and save. And it then gets all of this, and it copies all the files to the... Wait, let me look into this. Yeah, it copies all of them from this autofill source paths, which is the path profile appended with autofill's name, and it just copies them. Wow, what? Wow, well, yeah, that's just got me bit shocked. Ha, wow, yeah, uh, yeah. So next thing it does, it collects the system information, and we can just man system profile sp software sp software data. Is there any more information? Wait, no. One second. Yeah. So uses SP software data type. We can just have a quick Google. And SP hardware data type. If we remember earlier, it used the SP hardware data type to check if it's a virtual machine. I'm obviously not going to run this, as this would give away information about my system I don't want to share. But if you do have a macOS, you can run this on your own system. And once it's executed that with this, so this creates a new task, allocates it and initializes it, which literally could have been ns task equals ns task new, as Copilot so beautifully predicted. It's literally literally the same thing, but oh well. It sets the launch path to the shell script, and it sets the parameters to the command -c and command. So as an example, -c man. Oh, okay. Oh, actually, that wouldn't work. But yeah, bin shell and just specifies the command, and we can remember it creates a pipe to capture the output and the errors to this single pipe. Then reads all the output and creates a new string and initializes it with this data, and the encoding is UTF-8, and it returns this new string back. One second, back to here. One thing I like about Objective-C is its automatic reference counting. If you remember back here, it does this auto release pool, and this auto release pool, I believe it specifies it allows the ability to not care so much about who owns what data, and it will do the memory allocations almost for you, if I understand correctly, which is quite a nice thing to have. So it creates a new dictionary, which is hashmap, and it splits the data, which is the data returned from system profiler for these two. So if we just remember this, so it splits it on, okay, each new line. So each new line essentially looks like model identifier Mac 1513. And then it splits by this delimiter. So model identifier is the key substring to index of the delimiter position. So up to here, this is a new key, and then the value is after this key plus this space to the end, and it stores it in this hash map, the key, model identifier, the value, Mac 1513. It stores the build ID, which we remember being stored in the globals back here as this. And now here, this is something interesting. It calls get IP, which accepts a lambda function, which is called completion, that does some stuff. So and if it's an error, then it just logs error function IP, and it initializes this system info dictionary, the IP info key to empty, else it sets it to the IP info passed in as a parameter to this lambda function, and then it stores the system OS MacOS, the system password, this system pass, and writes the system info out to the temporary path. If we remember before, the temporary path is something like, well, 1 second, it's like temp 25, and that's what the temp directory looks like. So it writes the system info file out to disk as a pretty printed JSON file. Oh my, we're in for a treat, aren't we? And it writes that out to disk. So now I find it quite weird that they do all of this in the lambda function. The only thing they maybe really had to do in the lambda function is like this, and maybe they could have done like this, and is that correct? Yeah, that looks correct, and that would have probably worked just well. I'm not really sure why they did it all like this, but hey, we can look into this get IP function. So the first thing it does, it fetches the IP from this JSON endpoint. It's we can actually look into this fetch URL. It uses the NSURL object, specifies this, and shared session. It's just a global, well, just something else. Yeah, shared. Completion handler. What is this? These are just convenience methods that for completion. Where is this? Okay. Oh, that's. Oh, okay, that's this. Go. If we jump back to whoever's calling fetch URL, this is the completion function. Well, if you jump back to this completion function is called with the result, with the data. I assume this is the response from this invocation, and I'm not going to bother reading through all of this. I assume this just passes the JSON, and if that wasn't successful, then it tries to get into another endpoint and does the same JSON parsing, and it just says it fails to get the IP address. I'm not going to look too much into it because that's not really that interesting. But we can jump back all the way to wherever we were before. Oh, we jumped too far back. And we can just start again from the main. We were control and manage, and we are in collect system info. Are we in collect system? Oh yes, we are. So what can we say this does? This collects the software, hardware information, collects the IP information, and writes it all out to system info. Collects software, hardware information, and IP, public IP address, dumps it out as JSON to dump system info.json. Nice. What is next? So this looks like file grab, and then we've got dumping keychain, the wallet data. So this is just so we've got some idea, and then this is the actual sending it off to the C2 channel, clearing it up. And what is the so we can look at this later, but let's look at what this file grab does. Awesome. Second, let me just look through this entire thing. Just have to relinquish myself with some water. So the first thing we do, run AppleScript with path. I am not that familiar with AppleScript, I'll say. Let me just say types. Let me just okay, it's a very interesting language. Okay, I think it just looks like English. We'll be able to get by fine, as there are comments. So we mute the sound to we set the base folder path as this. I assume we mute the sound so that when we're copying the files, that it doesn't make the sound as it normally does. Set notes folder to the notes. Set the username to use. I have no idea how this actually code. Wait. Check if the base folder path exists. So it creates this folder. Creating the file grabber folder. Then creating the notes folder. Okay, then it copies the Safari cookies. Oh, so this is something we missed here. For each different browsers. Wait. We can note that this does for different browsers excluding Safari on disk. And we can just, where were we? Back here, yes. So copies these Safari cookies. What is this? Oh, just system information. Then it sets the Safari folder to something like here. Then it copies all the Safari stuff. What is this? note store. Okay, so it copies the note store SQLite database, and then it copies the desktop files that are of text, docx, rtf, doc, wallet, keys, key. And then it does this for the documents. Does this do this for the downloads? No, it doesn't. And then it unmutes itself. Oh, ooh, one. Oh, where have we gone back? Let's go back to here. Run applet script with. Wait, 1 second. Let me just. Wow, that was a deep script that we went into there. I forgot where we. Oh yeah, so it runs this. Let me just collapse. Oh, I can't even collapse this string definition. Okay, yeah, I just thought. Oh, okay. So it executes this Apple script, which is this entire thing defined up here, and it attempts to do that 30 times. And we can have a look at what this is. So it replaces this with double backslash n with just a new line, and it writes it out to this location and temp disk in the temp folder, and then it tries to execute it with OSA script, captures the output as we've seen before with popen, which returns a pipe, stores the result as an in the buffer, and appends it to the result ns into a string, gets, and just debug logs that. Pretty straightforward. And if this fails, this tries to reset the permissions, which was tcc util reset. Okay, so this just resets all the permissions. So I believe reset reset Apple. I mean, I wonder ls. Okay, no, that didn't do what I thought it would do. Let me just look at the bundle ID. I can try code maybe. I'm not sure what the bundle ID is for VS Code. If I knew more about macOS internals, I'm sure I could have shown an example where we reset the TCC database for VS Code. So next time I did like LSLH, it would have given us a prompt to say, do you want to give VS Code permission to this? I assume that's kind of what this does, so we can get the permissions required to read those, the Safari, documents, and desktop directories. So if we go back to here, we can say collects Safari, browser data, notes, SQLite, database, and desktop and documents files that match the provided extensions. Reading my mind. We can just double check, we can just go over that one more time to read. Oh no, so create that to a temporary into the temporary folder. Oh no, so it stores it in the home directory, temp folder, into the home directory, plus I can go back here and I can go back. Please. Just want to double check that was the. Oh no, so it wasn't. Perfect. And next thing this does, I think the name is quite self-explanatory. It gets the location of the keychains database, and then it copies it to the temporary path, which remember it initializes as temp 25 characters, and this copy the keychain database into the temporary folder. And then tries this 30 times. If it fails, resets the TCC database with TCC util. I mean, I wonder if we just Google this TCC stuff down here. TCC util reset Apple events. Okay, OSA Apple events. Let's see. I assume Apple events. I mean, is the bundle ID for TCC. Next thing, collect wallet data. It's got these wallet paths. One thing I just want to have a look at again, this collect all data for the browser stuff. There are all these extension IDs. Did they let me just go to references. And I just think I may have skipped over this. Yep, so I did skip over it. Yep. So remember we've got the path to the profile and the path to save. And this gets, let's just work backwards. Goods definition. Good. Shift F12. If the extension IDs contains one of the entries within this directory of the extension paths setting. Okay, so takes the profile path, appends local extension settings, lists the contents of that within contents for each entry. If the entry is within, if the self-extension IDs contains this, then it formats the path to, it creates a new string path to save plus extensions plus the entry name, so the extension ID, and then it copies it. Okay, I'm happy we went into that because I missed that. That was my bad. I thought we had, we must have gone over it too fast. But we can look at it one more time. Oh no, not here. Browsers.m. What kind of? Okay, yeah. So it's just crypto wallets. Just still got the crypto wallet data. Yuck. And browser extension information. One second, I can just have a look to. You can just do Control FN Shift F12. Oops. Fn shift F12. It copies the full extensions, local extension setting. Copy. Browser extensions information. Nice, so we got that done. And collect wallet data. So we've got these this array of strings of wallets. Takes a temporary path, appends this path, takes the home directory, appends the library application support, and then for wallet in wallet paths, the source dir, which is the home dir plus the wallet path, the wallet name, which splits this, so X this, and then the destination dir, which is the temporary path plus wallets plus Exodus. So we temp 25 characters, wallets, then Exodus, and then if the source exists, which is the wallet path, then we'll just copy all the files into the temp folder. Okay, pretty simple. Copy, create. Wallets dir under temp folder, and for each wallet try to collect the wallet, try to copy the wallet data to temp folder. And now this is what it does: collect all the compresses the folder and ditto. Okay, so that just creates an archive of the folder path, which is unsurprisingly the temporary path, and it just executes this command, compress. It compresses it into the folder path. Yep. .zip. Okay. A second. Let me just don't save changes here. Compress it. And now, if we look at the sender, there was no initial. One sec. The sender. Okay. Yeah. We jump back down here. Send data. So it takes the remote IP. Go to data. This address. And the send endpoint. Oh. It takes a random key. Wow. My keyboard's not working. It takes a temporary path plus the zip, obviously where it's been compressed to. It reads the data of this zip folder into memory, probably what it should have done all this time. It encrypts it with this key. It base 64 encodes it. What are these options? Alright, Google. Options. Here. 0. Oh. So it's used to control the line length. And it gets the folder name. Wait, last path component. Okay. And then it turns this into a dictionary, as we've seen them use dictionaries before to write out the system information, if you remember here. Here it uses stores it as a dictionary, and it uses this dictionary system information as a JSON. It serializes it and writes out to disk. So this a similar thing. Like most languages that aren't too low level provide like the ability to serialize dictionaries into JSON structure as is. So data, and then the basics for encoded zip, the key and the folder name, serializes it, and creates a semaphore. And this semaphore is just some sort of synchronization, and then it posts the data to the C2 server. So the C2 address, if we remember, is just this remote IP. This JSON string is this dictionary value serialized, and so it'll be data and the basics for encoded string, the key, the folder name. And it waits forever for this semaphore to be signaled. And okay, that's this completion thing. And so this function waits for this to be successful before it returns. Okay, makes sense. And this just posts JSON to this URL. Pretty straightforward. And we can oh Jesus. Oh, what is going on? Read the zip. Okay, read the compressed zip into memory. We can just have a look at how it does this again. Into data. How did it encrypt it again? XOR encrypt. Wait. XOR encrypt. Okay, yeah, literally. XOR encrypt. The zip data. There's a mutable copy of the zip data with a 15 a string of 15 characters, and so encrypt with a key of Charles. Wait, let me just double check. Is this definitely 15 and not 16? Yeah, okay, it's 15. And basics. Base 64 code data store in map, serialize the map into JSON via post request, signal the semaphore so the function it can return. And then this just, yeah, not that interesting. It it gets all the contents, recursively deletes, contents, remove the Apple script created by system file grab, remove folder used for Apple script data collection, good stuff. Oh yeah, and this is just recursive. Oh jeez. What is this? 1, 2. remove recursively remove all files under this folder. Alright, what we can do is those contents. Nice. I think that is the main kind of everything. Let me just double check to make sure there is nothing I missed. So how does it work? We remember the first thing it does, it relaunches itself with two parameters, run controller and the argument, the encryption key. Then it allocates and initializes itself with the encryption key and then calls the manage class method. First checks if it's being debugged with the ptrace check. It then checks if it's running in a VM by getting the hardware data and checking if the model identifier contains virtual. It then initializes this global temp path, which is under temp plus a random 25-letter string, and this is where it will store all the collected data during the data collection process. Next, it gets the macOS password with an OSA script, which essentially displays the dialog like this, password, and it tries to validate this password using where was it, with the DCSL. If we man DCSL, which is Directory Services Command Line Utility, against the, double check, the data source, which is local default, and it tries to authenticate. So this tries to get the current user's password. Then it collects all the browser's data, well, not all, only Chrome, Firefox, Brave, Edge, Vivaldi, Yandex, Opera, and Opera GX, as we can see, not Safari. And for all browsers, it tries to get all the paths. For all paths, it tries to get all the extensions. And if the extensions match one of these crypto wallets, then it will copy all that data as well. And then for all browsers, we see that it copies the web data, history, cookies, logging data, the autofills, history, cookies, and passwords to the temp folder under a representative data folder. It then collects all the system information, the software and the hardware data information. Then also stores this in a dictionary, this dictionary system info, and it tries to get the IP address from several sources if one of the sources doesn't work, and then it stores this IP information in this dictionary. We can remember that we made these changes because it really didn't make sense for them all to be in this lambda function, but we store the OS as macOS, the password as the password from that was recovered in this function, which is the get macOS password, the OSA prompt we previously saw. After that, we write all the system information back to the system info.json dump by serializing the dictionary as JSON and writing out to disk. And jumping back, we then grab the Safari browser data using this OSA script, which copies it to this this folder in the home directory. So this is something we missed: the source path, the destination path. So yeah, it writes out this script path to disk, and this is it writes out the script to disk and executes it, and that collects all the Safari notes information. Then dumps the keychain passwords by copying it to the temporary path under the passwords folder. And then collects all the wallet datas. Pretty simple. Compresses it as a zip file. Then this function reads all of the zip file into memory, encrypts it with a random 15 length string, 30 bytes. Encrypts or encrypts it as a mutable copy, passes it as a mutable copy, base64 encodes it, stores it in a dictionary with data as the key, and then an array. well, no, an NS string with the base64 encoded zip data, the key, the folder name. Uh, that syntax is a bit weird. Yeah, okay, no, yeah. String. Okay, oh, no, okay, so yes, it's data, and then this is not an array, this is just this format string with the base64 encodes zip data, colon, the key, colon, the folder name. It serializes this, posts this to the C2 server, has this semaphore which waits until, has this semaphore which the function waits on until this completion function signals it as done. And this just posts to the C2 server, and then it cleans up the Apple script and it removes all of this stuff off of disk. I think we have finished exploring it. We've got a good understanding. I've learnt some stuff. It's been pretty fun. What would I say is good about this? Oh, it kind of just works, doesn't it? What would I say is bad? It kind of lacks evasion. For example, if we look at all of like these these strings, for example, these strings you can use a compile time string obfuscation framework like adobfuscator, which uses macros that compile time to encrypt strings. And yeah, we remember seeing Conti use this as well. So using something like that would be good. What else kind of sucks about this? I think that's the main thing. I think another thing that could have been done is in-memory loading of the actual Stealer content, so it's harder to reverse engineer the stuff. But hey, that being said, if it is this easy, I think there's a good thing for defenders as it makes their lives a lot easier. But if this was a red team tool, a lot of this functionality wouldn't exist in the red team tool. But yeah, some of like the anti VM checks, this is like terribly stupid. I mean, the is debugger attached check, we can just like patch this call so easily. It's not really good checks. I don't think we saw this being referenced anywhere. No. But this is just something that just gets to the preference preferred language locales and then checks if any of them contain RU. I mean, hey, if you want to protect yourself against from a stealer, heading down to your preferred languages and add the Russian locale. Yeah, I'd probably there's not another thing that copies everything into the temp folders, and while it does make it easier to code, it just has so much worse forensic footprint. Like any sort of endpoint security product is going to see you copying all these files from like browsers into the temp folder, which is like incredibly sus. And even just copying into temp folder is just stupid. You can better just read it all the files into memory, do it that way. Obviously that adds complexity, so I think there is like an engineering trade-off, so I won't bog myself down with this discussion. But yeah, thank you guys for sticking around. I hope you learnt something. If you want to get into like more macOS stuff, a great place is Objective-C. They've got some great talks, great resources. The guy behind it has some books, Art of MacMalware, and 2 volumes. The second volume just came out recently. I highly recommend checking it out. And all the chapters are for free, so it's awesome. Patchboard was invaluable to the macOS community. I highly recommend checking that out. Thank you for your time. I hope you guys have a lovely day.